Saxon Algebra 1/2, Lesson 85. Greetings, Caleb. We are going to begin a process that's going to unfold over the next couple years. We're going to talk about equations of a line. And I should say equation of a line because each line that we can draw, infinitely long, in either direction. Oh, excuse me, I'm not bored by your lesson, I'm just giving a little yawn here. There's an equation, a mathematical expression that will describe what that line will learn how to do first is take the equation and draw the graph of it. And we just have one lesson in which we're going to do that. Or not one lesson. There's going to be many, many lessons. We're going to have one problem in this lesson, example 85.1. And this is the line that we're given, y equals x minus 2. This is the way the equation of a line will always look. Once we get it organized the way we want it, and John gave us this one nicely, there will be a y term on the left, then an equal sign, and then an x that might have a number in front of it or even a fraction in front of it, and then a whole number, an integer, plus or minus, on the back end there. We'll talk much more about this format as we go, but this is a very special form that we'll be working with. What we're going to do to start is we're going to make a chart. P.S. We've been asked to graph this. And I'll write it down a little bit because I squished my line in with the title. Okay, so the first thing we do is make a chart. We know that in order to graph things, we have to have an x and a y, right? We're going to graph it on a thing like this, right? The Cartesian coordinate system. And you know how to plot points on here, which is all we'll be doing. We'll plot points and then we'll connect them, but I just want you to have a vision of where we're going. So the first thing we have to do is come up with some pairs of points that we're going to be graphing on here and then connecting. So what we'll have is we'll choose some x values, and then we want to come up with some y values, and we'll use this expression, what's on the right-hand side of the original equation. That's what we'll use to transform our x's into y's. So here's the thing. This and this will always be the same. This expression in the middle will come from our equation. Okay, it'll always be the right side of the equation. To start creating pairs of points, we get to pick some x values. Okay? So we pick and by some I mean 3 simple values. Anything we want. Now, I drew this graph and I can see, let's see, I can go up to 4 pretty easily. I can go down to -4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay? So that's roughly how big the scale of our graph is. Now, if I wanted to get a great big piece of graph paper and draw a giant graph, I could pick I could pick 27, I could pick 142. I could do it. It would be fine. I can subtract 2 from that and come up with the matching number. But why use big numbers when we can use little numbers? Let's try and choose values for x that are going to keep our answers right here in this simple area of center area. So what I'm going to do, I'm going to choose 0 as my first one because that keeps me really close to the center. Then I calculate 0 minus 2. Okay, that would be minus 2. So there's my first pair of points I'm going to graph. 0 minus 2. Now, if you were sitting here, I'd ask you to pick another number, another value for x. I'd say, keep it within +4 and -4 so that we don't have to graph across your table. And I'm going to pretend that you said to me, let's choose +3. Okay, 3 minus 2 means the y value associated with 3 is 1. So there's our second pair of points. And then I'd say, okay, let's challenge ourselves. Let's choose a negative number. I'm not going to choose an extreme negative. I'll choose -2. Okay? -2 minus 2 is -4. So there's my third pair of points. okay? 3 is the number of values that we always want to choose for x. I'll explain why once we draw the picture. Okay, so now I've created my chart. The second thing I want to do is graph the points that we created, right? We created points, pairs of numbers. This is the x value, this is the y value. I think you're really comfortable with this. So now we're going to graph them. Here's the first one, 0 and -2. Oh wait, 0 and -2. 3 and 1, -2 and -4. Okay? Now, if you've got a ruler handy, I'll just use another marker. You can use a straight edge and connect them. Before I draw the line, I want to point something out to you. I hope you can see it on the camera. When I use my straight edge and line it up like this, I can see, oh, those 3 all fall in a line. That looks good. I can draw my line and connect them. Oh, my marker rolled. As, you know, one could have predicted it would. Okay, so there's our line. The name of this line is y equals x minus 2. Every single point on this line represents an x value where you subtract 2, and that's what the y value will be. Every single point on this line will make this come true. Oh, isn't that happy news? Not this, that's my marker roll. Excuse that, please. The reason we do 3 points is that if you just did 2 points, you wouldn't know if they were both correct. If you do 3 points and they all fall on the same line, you can be pretty sure that your points are all accurate. But if you only do 2, you won't know because 2 points will make a straight line no matter what, right? But if you add that third point, then that will catch any errors. So that's why we want to always graph 3 points instead of just 2. All right, we graphed a line. We learned that this is called the equation of a line, and we can convert it into a picture, and we're using the chart method. Later we'll use a different method that is, it doesn't require us to make this chart. We can do it faster and easier, but for now we're going to practice this chart method. All right? That is lesson 85, Caleb. Short and sweet. See you in 86.